Also, we'll go ahead and add in a little while, or in the next day or two, hopefully after this is all hooked back up correctly. It's a video just showing it operational while it's hooked up and where everything falls and how everything's wired out there. I know it's a little bit of a mess here on the table, but just to show you that this isn't how it looks, you know, while it's obviously being used. Alright. Alright, today we're going to take a look at a Mighty Mule gate opener. As you probably have an issue already, this one does. Its main board fried about 6 months ago. So I went ahead and changed it out to this. This is an Arduino unit controlling a relay shield, which is going to a automotive style, or no, air conditioner style relay system, double pole, double throw relay. The benefit of this is it is not nearly as expensive. The other last one I had broke twice. The first one lasted about 2 months. This one lasted about 9 months or so. It's just not worth replacing. A board, it's about $300. So I came up with this, the idea of using Arduino, and I found out that somebody already had, Mr. Mark Cash, who's got a YouTube channel that'll be linked to this video at the bottom. Actually had done this already, and this is what it's based on. If you want information about that, I'll leave a link to his channel where you can check out his original video, and you can contact him if you want the sketch for the Arduino, since I do not own the rights. Okay, this total system costs about $100 versus, like I said, the board that's for this unit, which is a model I believe is a 360. I believe the board costs somewhere around $300. The parts you're going to need for this are going to be, like I said, your Arduino Nano. I went ahead and used a screw terminal right here. I got a device to sense the voltage, and also two of these double pole, double throw relays, and then 2 of these relay shields for the Arduino. Also, you don't need this one, but you need some sort of clicking device. You can even, if you have a keypad, you can use those as well. This is a Mighty Mule sensor. Since I had a bunch of these remotes already, it made sense to just go ahead and get the Mighty Mule receiver. You can get these for about, I think, $40. You can get the 2-channel generic ones for $15 or less on eBay. Well, also we got one of these $5 Harbor Freight quality battery float chargers. It serves its purpose. And also one of these 12 volts to 5 volt DC converters. That way we can go from your 12 volt battery power down to your 5 volts for your Arduino. Okay, and then I don't think I mentioned. And then you need a limit switch for your close. Instead of using the rotating disc wheel that's inside that counts the number of rotations to close, we're using now a limit switch. That way it's definitive. When it's closed, it turns off. That seemed to be one of the bigger problems I had with the Mighty Mule board. It would occasionally lose its programming. This way, when it's closed, it's off. Okay, so just to show how it works, click it, forward, reverse, it stops just like normal. And then you can also set this to 100, set I believe 120 seconds for the auto close. That way, if you go ahead and open it, it'll automatically close behind you. I don't use that on mine, but you can. Let's look for it. You get your power coming into the 12 volt battery right here, which is tied into all your other 12 volt stuff right here. Your charger, and also your 12 volt power going to your converter, and also down to your relays over here, which we'll get into in a minute. Got from there, your 12 volt power actually going to your unit. Comes in from here, it goes through the sensor here, which is going to detect high voltage spikes, then it goes out to your board over here. I went ahead and tied it in actually to the original switch. That way, if there is a problem, that way if you do have an issue, all you got to do is just flip the switch. That's about all that controls though. It just cuts off your power to there. This way. Alright. You can see on these take your power from your Arduino and it transfers it to 12 volts. So in this side you got your 5 volt power coming in. This side you got 12 volts coming, actually no, you got 5 volts coming out of there. Yeah, this takes your 12 volt power to here because these need 12 volts to be able to open, and these allow much more flow, and also it allows for the switching action that's going to be happening. On these, so you can see we've got your limit switch connected down here, grounded here. That's your orange wire. And then on the other side, we have your green wire coming down here from your limit switch inside. You can also look on the original schematic and see I believe it's the brown wire that you tie in back to your Arduino for your auto closure. Since we're not using that, we didn't have to fool with it. Here you can see we tied, if you look closely, you can kind of see where we tied all your reds this side and your negatives to the other. That's all there is to that. Then over here you can see, of course we got the common for your second limit switch is tied in over here to your neutral, to your negative, and then it's tied in on the other side down here, and then same thing, just same position that your green is on this one. Okay, your signal wire coming in from this is the closed one, this is the open one. So on here, your signal wire, which is normally open, is coming down to here, and then same thing on the open one, it's coming down to here, down in here. Then from there, it's going to tell it, since these DC motors just rotate polarity, having two of these allows, since they're double pole, double throw, it allows it, we can just basically one is one way, the other is the other way, and it comes down into these connectors. So on the output side, the input sides are identical, but on the output side, they're opposite. Green, or basically red, black, and this is black, red. To look at it easily. That way, one's open, one's closed, just flip-flopping. Then you've seen the inside already. We've seen this one when you go to close. It's automatic, and then when you're closed, and for opening, when you hit it, that stops it. That's simple. Okay. Like I said, I've been using this for the last 6 or 8 months. I've been waiting to do a video until I made sure how reliable it is, and I took this time now to pull it all off and try to clean up the wire some. It's still kind of a mess, but it does work. Much cheaper. I find it much more reliable. And it's not pretty, not supposed to be, but it does work. So if you're trying to find an alternative for your standard opener. One other thing to note in this will work with all your other standard accessories. I do have it hooked up to 2 keypads, and if we want to look a little bit closer here, right now I got a mess of wires. But this opener, a couple extra down here. You don't use the yellow and the brown. Your red and your black just tie into your 12-volt power. That way, you know, you always get standby. Down here, you tie these into pin, or to the ground, and then to pin D2. This is your green and your blue. These two allow you to connect any kind of accessory. This is just what this uses, but if you're using any other kind of accessory, the keypads, like I said, I got 2 of them, one on the inside, one on the outside to open. Also, if you got like the exit wands, all work fine. You can also add in, what I do have, and I haven't hooked it up yet, I'm going to do it in a little while hopefully, the lock on the... You can also continue to use, if you have a solar system or you want to go to solar, that's always an option too. Since I have power out there already wired, I just went ahead and picked up one of these for $5 since it's cheap, simple cheap fix, and so far it's been working fine.